Okay, so now let us solve these questions to see why you had a little bit of difficulty in this exam. So your calculation should also be actually, you should be very fluent in these simple calculations. I mean, the only bad question which I don't like it myself is this question. Yes, I don't like it, but we have to live with it. Yes, that's life is not about what we like. Usually, it's about what we don't like. So anyway, but other questions should be straightforward and sometimes good. I mean, let's see. So the first question, this function is this complex number is given to you, and you are supposed to calculate this number, imaginary of z minus 2 real part of z is what? And this I would consider really E-level question. So what you do, we start simplifying it, but do these calculations once patiently, not under stress. So what I will do here, I will raise this one to power 2 first. Yes? This is a standard way of doing it. So the first one is squared 4. 2 times the first one times the second one, 12i. The second one is squared. What is that? 3i squared, but I squared, no, sorry, 9i squared. I squared is minus 1. So let us write just minus 9. Yes, don't write so many things. And then what happens here? This one and that one becomes minus 5 plus 12i, and then you have 2 plus I. Okay? And then you know that if you want to divide two complex numbers, there is only one rule: to multiply by the conjugate of the denominator. Yes? So what you do? So you write it as minus 5 plus 12i divided by 2 plus I, and then you multiply it by 2 minus I, 2 minus I. Okay? And then the denominator becomes what? Conjugate rule. 4 minus I squared. And I know that I have to multiply, so it becomes minus 10. Minus 5 times minus I plus 5i. And then what do I have? I have 12i multiplied by that, it becomes 24i. And then 12i times minus I is minus 12i squared, but I squared is minus 1, so it becomes plus 12. Right or wrong? Okay. But the denominator becomes what now? 5, because I squared is minus 1. And then this one with that one is simply 2. And this one with that one is 29i. But this is not still a standard form, so I have to write it as 2 over 5 plus 29 over 5i. That's it. This is the simple calculation. And then you need to answer the question mark. The answer to the question mark is the imaginary part of z, which is 29 over 5, minus 2 times the real part, which is 4 over 5. Yes? And then what you can calculate, it is just 25 over 5, which is simply 5. So, I don't know, I wrote all the details. If you can do some part of it in your head in a quiz, it is probably better to do that, yes? Next question. I don't think, in total, I think only one person answered this question correctly in the whole Natur and Technique program. Yes? So how is that possible? I don't know. Did you see this minus sign in the question or not? Okay. So if you see that, you cannot use these numbers. Yes? Because this, in which quadrant is z? Third. So in the third quadrant, how is that possible that you have 60 degrees, 30 degrees, or I don't know, 120 degrees? Yes. Okay, so let us go back and solve that problem. So I want to find the polar form of this complex number. The first thing I want to do, I want to put it in the standard form. The reason is that because I need to find the absolute value. So I would write it as minus the square root of 3 over 4. But this minus sign also goes there. So it becomes minus 3 over 4i. So that is the complex number that I'm facing. Yes? So now I need to find the absolute value of z, which is called r. Do you remember? It's the square root of the real part squared. Do it in your head. This one squared becomes 3 over 16. plus this one squared becomes 9 over 16. But 3 plus 9 is 12 over 16. And 12 and 16 are simplified by 4, so 3 times 3 over 4. But the square root of 3, 4 is the square root of 3 divided by square root of 4, which is 2. So this is not helping you that much because all the options have a square root of 3 over 2. Yes? The only thing that you have to be careful is the argument. And I told you for the argument, do you remember tangent of alpha is equal to the absolute value of the imaginary part divided by real part. Okay, so this becomes absolute values. The imaginary part is minus 3 over 4. The real part is minus the square root of 3 over 4. So 4's are gone, minus signs are gone, so it becomes 3 over square root of 3. Okay, might be that is my trick. So I don't know, might be you don't find this number in the table. I don't know how many of you face that problem. Okay, but this 3 over square root of 3 has a better name. What is that? The square root of, okay, if you know that, then I don't know why you made a mistake there. So that's the square root of 3. And alpha is what? Alpha is 60 degrees. You can see it in the table. But because this is in the third quadrant, do you remember when I was teaching you, I told you that the theta, the argument, is equal to alpha if you are here. It is equal to 180 degrees minus alpha if you are here. It is 180 degrees plus alpha if you are here. And it is 360 degrees minus alpha if you are here. Yes.
How do you know if it's in the third quadrant?
No, because both of them are negative. The x is negative, the y is negative, yes? So it should be the third quadrant. Okay, so this is 180 plus alpha. So theta is 180 degrees plus alpha, which is 240 degrees. So your complex number in polar form is your square is absolute value. Cosine of 240 degrees plus I sine 240 degrees, yes? On this, which option it depends because it shuffles. So in this, what you see is the last one. But some of you might not be, this is the case. I don't know. So it was not hard, you know. Okay, so 2 questions finished now. Oops. Question number 3. So question number 3 is not a bad question, to be honest. I mean, consider the following complex number. This is this complex number. You want to find the absolute value of z plus z bar, the conjugate, and write it here. Okay, so I have it on the board, so let me just do it here. So what should I do for here? I don't know. What is your suggestion? I mean, if you don't know how to deal with whole things, you can just do it piece by piece. For example, let me just concentrate on this one. If you don't like to work on the whole fraction, you don't need to bother yourself, yes? But you know that the common denominator should be taken into account. So it's because this one multiplied by 4 minus 3i, yes? Let me see if I'm recording, yes. And then this will go there, minus this will go there. Yes? Is that right? So I am taking the common denominator, this to this. This is the scaling factor. So I scale this by that, and I scale this by this. Okay, so just open up the pair of brackets so it becomes 4 minus 3i minus 4 minus 3i divided by. What is this number? This is 16 minus 9i squared. Yes? So in the numerator, 4 and 4 are gone. Minus 3i is minus 6i. And what is this one? I squared is negative 1, so 9 plus 16 is 20. Yes? This is not the whole z, this is just the denominator. Now z is 6i divided by what I got for the denominator. So my experience is that you have hard time to understand sometimes these things. What is the answer to this? Minus? Minus 1. Why is that? Because this one and that one are simplified. 1 over minus 1 over 25. So it becomes 25 over minus 1, which is minus 25. So z is this one. Okay, but then what is in the question? I need not only z but z bar, but z bar is what? Because z is a real number, z bar is the same. Yes? So the question mark becomes what? Absolute value of minus 25, which is absolute value of minus 50. The answer is yes. So it was not hard. So I agree. The only bad problem, to be honest, that I don't like it myself is this problem. So, but then we have to find a way to get rid of it. You know, but I mean, you don't have to. You see, if you don't like the question, first of all, you can just leave it and go to the next question and do everything and come back again. Okay, you don't need to actually start doing this. But what do you do? This is my advice to you. I told you that whenever you have fractions are problematic for us. So let us get rid of them first. So what I do, I will multiply everything by this one and that one so that all denominators are gone. And I know that sooner or later I have to multiply this in, so I don't do it step by step. Let us just do it in one go. I mean, in one stroke. It's not hard. You multiply this in, and then you have a minus 2i. This is on the one hand. The same story there. 2y minus 3iy plus I. But I told you that I want to get rid of denominators, so I multiply everything by the product of these two. But when I multiply that, this one and that one I'm multiplying are cancelled, but 3 minus I is left, so 3 minus I will be multiplied here. Yes? And then I have a plus sign. 3 plus I will be multiplied there. But on the right hand side, I have I multiplied by 3i, 3 plus I, 3 minus I. Okay, let me wait for you. Are you following what I'm doing or not? Yes? So I multiplied everything by this combination. Yes? When I multiply this here, 3 plus I are gone, 3 minus I is left, which will be multiplied to the numerator, but to the numerator I opened it up. And then when I multiply this here, 3 minus I are gone, 3 plus I is left, which will be multiplied into the numerator, but I opened up the numerator. Yes? I myself agree, this is a little bit boring question, but you should be able to do that. Okay, by the way, it's not big. So how many terms will be involved? 6 terms, 6 terms. Okay, 12 terms is not a big deal. Yes, 12 terms. Yeah, it's not. Yeah, we can just. This is not 12,000 terms. You know. So what happens here? This is extremely simple. So this one is what? What is this number? It's 10. 3 squared minus I squared becomes plus 1, so 10, and it is just 10i. So the right hand side is extremely simple. It's 10i. Remember. I go back here. Do this once patiently. Okay, so 3 times x, 3ix minus 6i, yes? And then I go to minus ix. Minus I times I squared is minus I squared. Minus I squared is plus 1, so it becomes plus x. Yes? Minus I times minus 2i becomes plus 2i squared. But I squared is minus 1. Yes? And then I do this one. So it becomes plus 6y minus 9iy plus 3. Oh, sorry, 3i. 3 times that, correct? That's correct. And then I go to I. So it becomes 2iy. This one multiplied by that one is minus 3i squared. I squared is minus 1, so it becomes 3 plus 3y. And then finally, I times that is minus 1. And do you remember on the right hand side we had what? 10? Yes? Okay, let us see how it goes. So, you know what to do. You need to separate the ones with I, the ones without I. So the ones without I have a 3x here, another x here. So it becomes 4x. And to be sure that you are not messing up, just cross them over, yes? 3x plus x is that. I have to look for the places that I do not have any i's. So 6i here, sorry, 6y here, 3y here is 9y. Yes or no? I cross them over not to get confused. And then I have minus 2 here, minus 1 there. It becomes minus 3. Yes, am I right? Now what is left for me is with I, so I factor an I out. So I have 3x minus x is 2x. So I consider these two terms. And then I have minus 9i plus 2iy there. I put I out, so it becomes minus 7y. This is also considered. And I have minus 6 plus 3 is minus 3. This is also considered. Yes? You see, it was boring, but it was doable. And then it is equal to 10i. Then I get a system. The system is what? 4x plus 9y minus 3 should be 0. 2x minus 7y minus 3 should be 10. Yes? And I need to solve the system. Yes? What should I do for the system? I multiply this, for example, by minus 2. And then add it up. So it becomes 4x plus 9y minus 3 equals to 0. This becomes minus 4x plus 14y plus 6 is equal to minus 20. Right? And then I add them up. This one and that one are gone. This is 23y's. This becomes minus 3. Sorry, plus 3. That is also minus 20. So you move this to the other side. And then y becomes simply minus 1. Yes? Y is minus 1. And if y is minus 1, I put it in one of these. For example, let me put it in the first one. So 4x minus 9 minus 3 is equal to 0. X becomes 3. Yes? And the question mark is x minus 2y. So it is 3 plus 2, which is 5. So the answer to this question is 5. You see, I agree with you. It is very boring. But I don't know, I didn't take the time, but even by explanation, I don't think it took more than 5 minutes. Okay? So, but let me wait a little bit to go to the next question. Solve this question now. So here we are supposed to, this is the complex number. I want to write this complex number in its simplest possible form. So do you remember what that formula is related to this? You don't need even to remember the name, but exponential form, but this formula is called the Euler's formula. I mean, you can find it in the formula sheet, yes? So what we do, so I don't know in which letter they have used to write it in this formula sheet, but what is the formula? E to the power of I theta is cosine theta plus I sine theta. Yes? This is the formula. So you could find it in the formula sheet. But now let us do this step by step. E to the power of I pi over 3 is equal to cosine pi over 3 plus I sine pi over 3. Yes? And then you can look it up in the table of values. This is one, I have it in my memory, but you can check it on the table. And this becomes square root of 3 over 2i. That's it. And by the way, I will break the points. If you write something relevant, I will still give you the points. So then you can realize how stressful is that if, for example, if you want to do GRE test. So in the GRE test, they don't care about what you did in your paper. What they care is the final result. So e to the power of minus I pi over 3. What is the difference here? You need to imagine that minus I pi over 3 is actually I times minus pi over 3. So you need to understand here, theta is minus pi over 3. That's it. So it becomes cosine minus pi over 3 plus I sine minus pi over 3. So you need to remember a little bit from trigonometry. What happens for cosine with minus? It will be eliminated, so it becomes just cosine pi over 3. But do you remember what happens for sine? The minus sign will go out. So it becomes minus I sine pi over 3. And then again the same story, cosine pi over 3 is still 1/2. And then this one is minus square root of 3 over 2i. Okay? Now this is the question mark. So the question mark is 2 square root of 3. And then the first number is 1 over 2 plus square root of 3 over 2i minus the second number. Yes? But this is extremely simple. So you see it was nothing actually. So 2 square root of 3. I open up the pair of brackets. Can you do it in your head? Minus 1/2 and 1/2 are gone. But this is minus minus, it becomes plus. So it becomes a square root of 3 over 2i plus another square root of 3 over 2i. Which is how many square root of 3's now? So yes, it becomes 1 square root of 3. Because the square root of 3 over 2 plus the square root of 3 over 2 becomes square root of 3. So it becomes 2 square root of 3 from the beginning. This becomes a square root of 3, but I also have an I. Yes or no? Okay, square root of 3 times the square root of 3. 3 times 2, 6. 6i. So the answer is 6i. Yes? Yes. Okay, so the exam was not that hard, to be honest. Let us go. The two good questions are the next questions. So the next question, question number 6, is telling you that z1, z2, z3 are the roots of the equation. This. What is z1 plus z2 plus z3 equals to? What I want to find the sum of the roots. I don't know. I was hesitate to put this hint there, but so it didn't matter because even if I put the hint there, nobody could solve the problem. Yes. Let alone, I don't know how many of you realize, if I didn't give you the hint, how many of you could realize that you should do something like this? Because my impression was that many of you will start raising it to power 3 or something like that. Yes. I don't know. So, take experience from your mistakes. Okay, so let us solve this one. I don't consider this a hard problem. Yeah, but this is technical. It's A-level question, of course. So let me write the problem on the board. Okay, let us solve it. So I have given you the hint that take capital Z to be Z minus 2i. I mean, by this hint, it is immediately understandable that my goal is to write this. Yes? And this is a very standard problem. That is actually the topic of one of the lessons. Z to the power of n equals to double. Yes? That's it. So do you remember what we should do? We need to say that let z be what? R cosine theta plus r sine theta. This is the method. So if you have forgotten, then of course you will be in trouble. So for these kinds of equations, we need to invoke the polar form. So what should we do? I would say that, okay, I put it back in my equation. It becomes r to the power of 3. But you know that in principle, power of 3 will go there. But hopefully you remember the reason that we put in polar form. Because that power of 3 will go and will be multiplied here. Yes? So it becomes cosine 3 theta plus I sine 3 theta. On the right hand side, I will have 8i. Yes? Let me close the door. So it might be hard if I didn't give you the hint. But if I give you the hint, you immediately should recognize the form. This is exactly a standard problem that we spend one full session to learn. So in this problem, you need to say that, okay, I am looking for z, but let us say that the complex number z has this polar form. Then you put it here. I have to raise it to power 3. This will be raised to power 3, but you need to remember, this is the most important reason that we switch to polar form, is that instead of having 3 up there, I can put 3 there. And then do you remember what was the next step? Yes? Yes?
I would say expand.
No. So if you start, it always works, but there is a better way to do it. Compare the absolute values first. Because I am looking for r and theta, r is immediately found because if this number is supposed to be equal to that number, the absolute value of the left should be equal to the absolute value of the right. The absolute value of this combination is what? Is r cubed. The absolute value of this is what? Not the square root of 8. You see, these are the, you have to be very careful in these calculations. It is just 8. Yes? And then it becomes what? R is 2. If r is 2, put it back into this equation, this becomes 8. And that 8 and that 8 are cancelled. So it becomes cosine 3 theta plus I sine 3 theta is equal to I. Yes or no? Okay. And then this is extremely simple because cosine 3 theta should be 0. This is a complex number. This is the real part. This is the imaginary part. The real part on the right hand side is 0. So imaginary part is sine 3 theta on the left, 1 on the right. They have to be equal. And what is 3 theta then? 3 theta is 0 degree, no, is pi over 2 up there. Cosine should be 0. Sine should be 1. We are here. So it means that 3 theta is pi over 2, but plus any 2n pi, multiple of 2 pi. But you remember I told you how many of them will give rise to, yes? No, because I have this, if that is the only one, yes. And if that's the only one, we have 2 answers. But if I have to have both of them, there is only one of them.
How can we be sure of that?
No, that's not hard. I mean, that is the way that we taught in the lesson. Of course, if you want to have sine to be here and cosine simultaneously, because if I say only sine 3 theta is 0, there are 2 places. One up there, one down there. So, and if I say this one only, yes, sine theta to be 1, so sine theta to be 1, there is only one place for it. Yes. Yeah. But I mean, if you want to take them simultaneously, this is the only one. So that's it. But then I told you that, of course, in the exam, you need to somehow use a little bit of your memory. Of course, if you want to analyze the problem, it takes ages. Yes? That doesn't mean that we shouldn't learn and do these things blindly. But I told you that only 3 of them is enough. What are the values? Because this power is 3, n should be 0, 1, or at most 2. Okay? So if I put n equals to 0, this is gone, so theta becomes pi over 6. If n is 1, theta becomes, let me write it. Might be you have problems understanding. So 3 theta equals to pi over 2. N is 1 becomes 2 pi. 5 pi over 2, but I need theta. So theta becomes 5 pi over 6. And finally, if n is 2, this means that 3 theta is pi over 2 plus 4 pi, which becomes 9 pi over 2. Am I right? I put 2, it is 4 pi, 8, 9 pi, yes. So then it means that theta, I have to divide by, this is 3 theta. I divide this by 3, so it becomes theta. Yes?
What is the answer in degrees? Or are you allowed to do degrees?
In degrees, yes. In this problem, you can do it in degrees. Yes. In that case, you have to write 90 degrees plus, for this one, yes, but for this one, no. For this one, theta has to be in radians, but for this one, yes. If you don't like this one, in this case, you can just use that. I don't know, if you told me in the beginning, I could switch to degrees. But anyway, but this is, of course, you got most of the point up to here. But the problem is not finished because I need to know capital Z first, and then after founding capital Z, I need to switch back to little z. So what should I do here now? Capital Z, so I have 3 capital Z's. I have 3 capital Z's. The first capital Z is what? R is 2, it's on the board. And then I have cosine of pi over 6 plus I sine pi over 6. Yes or no? This is the first. The second z, 2 cosine, what was the second angle? 5 pi over 6. Yes. Plus I sine pi over 5 pi over 6. And then the next one is what? 2 cosine of 3 pi over 2 plus I sine 3 pi over 2. Yes? So it might be I made a mistake in my own calculations. Let me see. Anyway, these are the three z's. But these are capital z's. So what should I find? The small z's. But the small z is not hard. What is a small z? The small z is capital Z plus 2i. Yes? So it means that if I want to erase it from capital Z to little z1, what should I do? Z1 is the old z1 plus 2i. So yes, I would erase that and write z1, then it becomes 2i. Yes or no? Understandable? Let me again explain it here. This is capital Z2, but I want to find little z number 2. Little z's from here, little z is equal to capital Z plus 2i. So if I want to find little z's, I need to find capital Z's and add 2i to them. Yes? So that is little z. And then if I ask you what is little z2, you will add 2i to it. And if I ask you what is little z3, you add 2i to it. Yes? And then what we want the sum of them. One way is to go and read all these numbers from the table. It doesn't hurt. But I'm a little bit lazy and I have some of them in my memory, so I want to use them. For example, I know that the trigonometry of supplementary angles, this is 30 degrees, this is 150 degrees, so they are supplementary. If they are supplementary, cosines are opposite, sines are equal. So if I want to find z1 plus z2 plus z3, I have to add everything you see here. But between them, I factor a 2 out. When I start adding them, this one and that one are gone because they are supplement to each other. If you don't like it, go to the table. This becomes a square root of 3 over 2 in front of your eyes. This becomes minus a square root of 3 over 2 in the front of you. You add them, it becomes. But because I know that they are supplementary, I know that they are. And cosine of 270 degrees is also 0 itself. So this is also gone. Okay, finished. And then I will go here. This one and that one. So this I remember, I think I made a mistake in my calculations when I was designing the question. Now, this one plus that one, they are the same because they are still supplementary. And sine of pi over 6 is 1/2. That is also 1/2. So it becomes I over 2. Because of that, this one is also I over 2. But I made a mistake because I don't know, for some reason I got it at the pi over 2. So this is minus 1. Okay? Yes? Right? And then I have 2i, 2i, 2i. So I have to fix that. And then what happens now? Just 6i. So yeah, because I had some, I am sure my answer was wrong. So the answer 6i is correct. Because I accidentally, when I was designing at home, I just used pi over 2. Okay? Sine of pi over 2 is 1. Okay, anyway. But the correct answer, I will fix the quiz, of course. The correct answer is 6i. Okay. I don't know if you consider this hard or not. Because in the book, this equation is considered to be level 2 problem. This is a C-level question in the book, which is the main part. The only thing that I make it A-level question from my perspective is just realizing that you need to introduce a new variable if you want to, and then use that variable to solve that equation. Yes.
If we take the original equation, so z minus 2i to the power of 3 is equal to 8i, can we just conclude right away from there that z can be equal, one of the roots can be equal Because if we replace z with 0, it becomes negative 2I to the power of 3, which is equal to 8I. So why doesn't that work?
It should work if you are right. So what are my solutions here?
Because I don't think n.
None of them is 0, yes?
Yeah. And
So
0
what
should
you are saying is that if I put 0 there, it should be, let me calculate, so it becomes minus 2I to power 3, so it becomes minus 8I to the power of 3, yes?
Yeah.
Which is I. This is a very good question, I don't know why. So then it becomes 8I, yes? So 0 is indeed a solution. Let me see. No, it is 0, one of the solutions.
Which one?
It is 0.
Is it 0?
Yes, because this is minus a half. No, this is 1/2. That is very strange. Because it is positive 1/2 for some strange reason.
No,
is
no,
Z1
no,
or
no.
Z2
This makes sense. One of the which one is it? It's the second one.
No, that is my problem. This is
That should be equal to minus 2I. Just the this
Minus
capital C
2I
part.
plus 2I.
what?
Yeah, there's no
The
contradiction.
capital C part, or the one in
This
polar
one?
form. Yeah, that should be equal to minus 2I, and then we add another 2I onto that.
No, but this is little z.
Yes, but the part that was capital C was equal to negative 2I.
Yeah.
So everything except the plus 2I.
No, but I'm still saying that what Simon is saying is that 0 is acting for the little z.
Yeah.
So
Yeah,
one
exactly.
little z should be 0. Which
And then-
little z is 0?
C2, little C2.
Little z2, but I don't see that. Because I see it is 4I.
But
Is it
should
0?
be minus.
It might
No,
be
because
that
yes, this is minus a half.
it's
Thank you.
minus
Yes,
and then
thank-
minus 1 times
Yeah, sorry. Because I thought that this is not 0. This is 0 because of adding to this one. Yes. So this one is 0. No, that is you are confusing me. This one is 0 because sine of 270 degrees is 0. Sine of 270 degrees is minus 1. So this becomes minus I times 2 becomes minus 2I, and then plus 2I is 0. So this answer is indeed 0, by the way. That's good. Yes. Yeah, this is why I'm not saying that this is a bad way, but I mean, if you could guess, you are, yet one of them is good for you, but this is not easy to guess the other two. Yes. So anyway, that's correct. Yes.
If you guessed one of them, then can you use long division to solve it?
You can use the long division. No. You can, by the way. I'm not saying this is the only way. If you insist to expand, when you expand, the last term becomes 8I, and 8I's are cancelled. Yes, if you want, let us solve it in that way. Anyway, let me solve it in that way as well. Okay, so let me clean this, and let us follow what you are saying now. No, because I was worried about the contradiction. I was thinking that, okay, this cannot happen, that if I do it consistently, then I will have in trouble. No, you are right. This answer indeed is totally 0. Yes? Okay. But if you want to solve that problem, you need to use this identity. Yes? You have it on the formula sheet, of course. This is the first one squared. This is, by the way, you know it. This is binomial theorem now in Math 5. So it's plus 3 ab squared minus b cubed. Yes? So if you want to use this, might be you are more comfortable. In this case, might be if you use this formula, that's also very simple. So if I put this to the power of 3, it becomes the first one cubed minus 3, the first one squared, times the second one, plus the first 3 times the first one, times the second one squared, and then minus the second 1 to the power of 2. Yes? If I want to use this, which is also in the formula sheet. So let me simplify this a little bit. This becomes z cubed. Yes? And then what happens here? It becomes minus 6iz squared. This becomes negative 12z. And then it becomes positive 8i. Yes, but to be honest, when I was designing the question, I didn't think in that way. But that is also very simple. Yes? Because this 8i and that 8i are gone, so if I write z minus, then I factorize. Then I am only facing a quadratic equation, which is, we don't need to do anything like that. Yes? Anyway.
That's how I solved it.
So, yeah, but the answer should be correct. Did you get the correct answer?
Somehow I did not.
Okay.
I want to see where I went wrong.
Okay. So z minus 2i is equal to what? 8i's. Instead of this, I put that expression. So this becomes z cubed minus 6iz squared minus 12z plus 8i is equal to 8i. And then I am lucky these 8i's are gone. And then what happens? Between these three, I can factor a z out. Yes? Yes or no? Okay. So one solution is z equal to 0. One solution is this one. By the way, I don't know how many of you remember the sum of the roots of a quadratic equation. We had this in Math 2. See, I told you. If you know that, this is even simpler, because I know that the sum of the roots is this number minus divided by this number, which is 6i. And then this is 0. So the solution, the sum is 6i. But if you don't know that formula, this is an extremely important formula. I want you to remember it, especially if you're interested in mathematics. If you want to have, then z1 plus z2 is always minus this coefficient over that coefficient, and z1 times z2 is this coefficient divided by that coefficient. These are very famous formulas in mathematics. But even though if you don't know that, because if you know that, then the roots here, z1 plus z2, becomes minus 6i over this coefficient, which becomes 6i. So the sum of these roots, I don't know them individually, but I know that the sum is 6i. One of the other one is 0, so the sum of all of them is still 6i. But if you don't know that, I don't know why, so you didn't. Did you reach to the same equation?
The thing is, in the time pressure, I didn't write negative 6i. I just
Okay.
wrote negative.
So if you want to solve it, then what happens? Z becomes minus b plus or minus this one squared, which is minus 36, and then plus 48 divided by 2. Yes?
Yeah.
And this number is of course not a very friendly number, but what is that? 12. So it is 6i plus or minus the square root of 12 over 2. Then of course one of them is 6i plus the square root of 12. The other one is minus. When you add them, what happens? It becomes 12i over 2, which is 6i again. So one root is 6i plus the square root of 12 over 2. The other root is 6i minus the square root of 12 over 2. Yes? If I add this one to this one, the denominators are the same. This one and that one are cancelled. 6i plus 6i, 12i divided by 2 is 6i. But anyway, so when I was designing the question, to be honest, I didn't think about that way. Because I am a little bit lucky, you know, because if this was 9i, then I would be in trouble. Yes, but still this method will work. Okay, so that's good at least. I mean, you have to be open-minded so that you can find a way. I mean, might be if I knew this is going to work, for me it's easier to do it in that way myself rather than going to these trigonometric ideas anyway. Okay, so might be the next question, and then we are done. So consider the following polynomial here, and then I have given you 4 roots, z1, z2, z3, z4, but I have specifically mentioned one of them. And then we are supposed to calculate this expression. Seems horrible, but that's not that hard. It becomes hard if you want to immediately start long division. Because if you start long division immediately, I told you shouldn't do that. Because this is a 4th degree polynomial. If you divide by z minus something, the quotient will be a third degree polynomial, then what do you want to do? Either you have to find another guess for that third degree polynomial. So that's not the wise decision. I mean, if you think about this, then might be you remember something when I was teaching. Do you remember what is the important thing about this?
You will immediately know one of the other roots when we're given first.
What?
The conjugate should be.
The conjugate would be the next one. Why is that? Every polynomial with, this is not always, for example, this, what I am going to say is not true for this polynomial. If I have a polynomial with real coefficients, the coefficients are 1, minus 2, 3, minus 2, and 2. All of them are real. Even though I am working in complex numbers, but the coefficients are accidentally in this problem real. If I have a polynomial with real coefficients, if I give you one root to that equation, the second root is always the conjugate of the given root. A second root, not the second, another one, the second one. Yes? So it means that this is the only problem here. If you don't remember this, then of course you will be in real trouble here. But still, if you have done the long division right, you'll still get some points, okay? But not the full point. So let me write it on the board and solve it and then finish the lesson, okay? So here you see that one root of the equation is given to you. Z1 is given to be 1 plus I. Okay? So I have already confirmed that myself that this works here. So I gave it to you as an information. But because the coefficients are all real, you need to remember another root. If you don't mind, let me call it Z2, because here this expression is symmetric. So you know I want to calculate Z1 to power 101, Z2 to power 101, Z3 to power 101, and Z4 to the power of 101 divided by 4 to the power of 25. So it doesn't matter which one I call Z1, which one I call Z2. In the problem, I call this one Z1 myself. I know that one of the other ones is the conjugate. So if you don't mind, because it is symmetric, let me call Z2 to be 1 minus 1. Yes? So I know that one of them, according to the problem, is this one. According to my own understanding of the problem, the other one is this one. So in principle, I just need to find the other two. Yes? Okay? So how should I do that? This means that my polynomial is divisible by what a polynomial? By z minus this expression. Because this is one root, the polynomial is divisible by this. Because this is another root, the polynomial is divisible by this. Yes? So the polynomial is divisible by that and that. Do you remember what is coming next? Yes? Yes. The polynomial is divisible by the product. So you have to be a little bit patient here to multiply this correctly. Yes?
Well, we talked about relatively prime.
This is relatively prime. Don't worry, because the first degree polynomials are always relatively prime. Yes, you are right. Okay, so here, what I do, I multiply them now. This was the very last lesson of complex numbers. Not the very last one. Yes, I think, yeah, that was the very last one. Okay, let me be patient and multiply them. So what do? I z by z is z squared. Z, I multiply it by the whole expression. So it's minus 1 minus I z. Then I multiply this by that. It's minus 1 plus I z. This one by that one. Minus minus becomes plus. 1 plus I, 1 minus I. Yes? Okay, what do I do next? Between these two, I factor a minus z out between these two. So 1 minus I is left from here. 1 plus I is left from there. And this is also conjugate. It becomes 1 minus I squared. Okay? This I and that I are gone. This is 2. It's minus 2z. And this is minus 1. So it becomes plus 2. That's it. Okay. This might be a little bit lengthy. First of all, it's a very trivial calculation, and this is the number, but this helps you because in the long division is actually very short now. Yes, you will see. Then I do the long division. Okay, so the long division should be done in this way. So z to the 4 minus 2z cubed plus 3z squared minus 2z plus 2, I divided by that expression I found right now, z squared minus 2z plus 2. So the first term by the first term is z squared. I multiplied and put it with the opposite sign here. The other one becomes minus, so it becomes 2z cubed. The other one becomes plus, I write it as minus 2z squared. And this one and that one are gone. This is a very good thing because this is also gone. And then you get z squared minus 2z plus 2, and then we are done because z squared by z squared is just simply 1. And then it becomes minus z squared plus 2z minus 2. The denominator is... Yeah, it is finished now. Do you agree? Because the polynomial pz can be written as this expression multiplied by that expression. So p of z equal to 0 means either this one is 0 or that one is 0. But this one is 0, I don't need to do it again because these are the roots. So the only thing that I was looking for is z squared plus 1 is equal to 0, and this is very famous. What is z? Z squared is minus 1, so what is z? Plus or minus negative square root of, so, but square root of negative 1 is? That's it. So the other roots are this one. So two roots, one root was given. Without even starting the calculation, I realized the other root because the coefficients are real. And then this is divisible by that, this is divisible by that, so it's divisible by product. So I spend a little bit of time to understand what the product is. And then I divided my polynomial to the product. I got this as the quotient, and I wrote this. That's a factorization. So the other two roots are plus or minus i's. Okay, so the question mark, I hope it's clear. So the question mark, so let me call one of them, I don't know. For example, I call that one z1, that one z2. Let me call this 3i and z4 minus I. Okay, so let us check the question mark. So the question mark is z1 to power 101 plus the other one is 1 minus I to the power of 101. The other one is I to the power of 101. The other one is minus I to the power of 101 divided by 4 to the power of 25. What happens to these two? They are cancelled because one of them is with positive sign, the other one with negative sign, and this is odd. When it is odd, it remains negative. So they are cancelled. So the only thing I have to do is to calculate these things. And might be you get it wrong, you want to switch to polar form and things like that. I'm not saying it's not working, but for this very simple combination, we can do it faster. So what can I do now? So the question mark becomes equal to this. Okay, so let us do it separately. For example, can you tell me how can I calculate 1 plus I to power 101? Of course, because this is a high power of a complex number, you might think to switch to polar form. It works. But in this case, you can have a shortcut, yes?
I would just write it as 1 plus I times 1 plus I to the power 100 first.
Yes.
And then I would write 1 plus I squared to the power 50, and that becomes...
Yes, exactly. So what I will do like this. I would write 1 plus I to power 2. But of course, this combination, you have to have a little bit of memory about that. Or you have to be able to foresee a little bit in the future. Why this is working? Because that's an exception. You will see why. This can be written as that because 2 times 50 is 100. Another one comes here, it's 101. The reason that this method in this case works because that's a coincidence. You know, if I raise this one to power 2, what happens? The first one squared, 2 times the first one times the second one. But the second one squared kills this one. And then to the power of 50, and then I have 1 plus I. So what happens? I squared and I minus 1 are gone. This becomes 2 to power 50. Then I to power 50. then times this one. Yes? But now what is I to power 50? It is 2 to the power 50, I to power 2 to power 25, then times 1 plus I. But I squared is minus 1. Minus 1 to the power of 25 is still minus 1. So it becomes minus 2 to power 50, 1 plus I. Yes? But now, let me see that if they say, I'm lazy to write it again, I want to do the other one with negative sign. So what happens this time? This becomes negative, this becomes negative, this becomes negative, this becomes negative. But when these two are gone, be careful, this negative sign does not change anything. Because of this even power, still it becomes 2 to power 50. And then I to power 50, but of course this becomes negative. Okay, and then this becomes negative. And then this becomes negative. Okay, so if I add them, so let me finally write z1 to power 101 plus z2 to power 101 is how much? Is this expression with minus this plus the same expression with negative sign?
No, because it's I to power minus I to power 50, right?
No, minus is gone. Because the whole expression is power 50.
Yeah, but because
No, that's correct.
no, because it becomes it becomes minus 2 to power 50 and then becomes minus I to power 50, right?
No.
No.
Minus 2I to power 50 becomes 2 to power 50 I to power 50.
Oh yeah.
Yes, yes. So this becomes what? I take a minus 2 to the power 50 out, it becomes 1 plus I plus 1 minus I. Then it becomes 2. So it becomes minus 2 to power 50 times 2, which is minus 2 to the power of 50. So the numerator is only this one, because you see that question mark up there, I am calculating this. I already know that these two are going to 0. The sum here is this number. So I have to divide it by 4 to the power of 25. And that is just a minor thing to do. Yes? So the question mark finally becomes minus 2 to the power of 51. Yes, minus 2 to the power 51 divided by, this means 2 to the power of 50. So what the answer is? Yes. Okay, so might be that was a little bit hard, I agree, but anyway. But still, if you lose this question completely, you still shouldn't lose the chance of getting even an A, because yeah, it was not, I don't know how you evaluate this. Might be that was harder, but not for your grades. I mean, your grade was so disastrous. Yeah, you were very tired. Okay, anyway. I don't be disappointed, because this quiz was harder than usual. Okay. Any questions?